Hi, and good morning. Welcome to this module of basic mathematics. I am Sankaracharya. I am a civil engineer from IIT Guwahati. We'll be discussing the basic math in this particular lecture. So the aim of this lecture is to present the students of class 11 with a basic understanding of the mathematical tools required to understand physics. By that, I mean these particular topics: the trigonometry, the equation of different curves, and calculus, right? Students coming from class 10 have little to no knowledge of calculus, so that part will be very, very important. In physics, we need a bunch of math to actually understand it, apply it in our real life. So only the theory part won't do. So a little bit of math is also required. And since these topics will be discussed in further detail in your math classes, we'll be touching only the introduction to these things so that you're able to just use them when required in physics. So it's not gonna be a very intensive math course, but an introduction to physics course. So that is a slight difference. Although this sounds like a math course, but it is going to be a physics introduction, right? So everything that we will discuss will bring in some examples of physics only, right? Okay, so let's start with the first part of this lecture, which is trigonometry, which should be just a revision for you because the basic trigonometry is taught in class 9th and 10th. And trigonometry, we all know it's a branch of maths where we study the relationship between different sides and angles of a triangle. And the trigonometric ratios are defined for the sides of a right triangle. And if I make this on my blackboard, and I want to discuss this in detail, so I'll make a triangle here. Right. Let this be the triangle here. Hit Control Z. Awesome. So this is a right triangle. I'm gonna name the endpoints or the vertices A, B, C. So angle B is gonna be the 90 degrees. So the longest side opposite to the 90 degree has a name. It's called the hypotenuse, right? We all know this. So an angle under consideration here, the angle that we are gonna find the trigonometric ratios for is this angle. I'm gonna call this angle theta. So the side opposite to this theta, AB in this particular case, we're gonna call the opposite side. Opposite side, right? And the side which is adjacent to theta, which is close to theta, is something that we call the adjacent side, or sometimes we also call it the base. The adjacent side, or sometimes we also call the base. So trigonometric ratios like sine theta, cos theta, tan theta are nothing but ratios of these sides. Sine theta is nothing but opposite side divided by hypotenuse. So if you have certain angle and you want to find out what is the sine theta for that particular angle, you need to find out the ratio between AB and AC. So AB being the opposite side of this particular angle and AC being the hypotenuse of the triangle. Similarly, cos theta is defined as the adjacent side by hypotenuse. Tan theta on the other hand is defined as the opposite side divided by adjacent side. So this is the basic definition of the trigonometric ratios, and there are some others as well. So sine theta, also we should know the full form of this. This is just a symbol. This is actually sine, right? SINE. This is the name of the ratio, sine. Similarly, this is cosine. I want you to guess this if you don't know. Pause the video and guess it, and then let me know if you are correct in the comments. Tangent, right? Okay, let's go for the other one, secant, or we call it sec theta. Sec theta is the symbol, right? And the name for this is secant. Okay, Secant is nothing but it is the reciprocal of cos theta, right? 1 by cos theta. So it is nothing but hypotenuse divided by the adjacent side. So if you have to find a secant of this particular angle, you take hypotenuse length and divide it by the length of the adjacent side. So there is something also called the cosecant. We call it cosec theta. Cosec theta is the reciprocal of sine theta, which is hypotenuse upon the opposite side. So this is cosecant. This ratio is called the cosecant. And the last one we have to talk about is cot theta, which is nothing but cotangent. Cotangent is the reciprocal of tan theta. So it is adjacent side divided by opposite side. So a few things that I want to clear here. Anyone who wants to note it down can pause the video and note down these ratios, their definitions, right? And one important thing that I want to mention here is that this opposite and this adjacent is dependent on the angle, right? So here I was talking about this particular theta, the angle C. So for this particular angle, AB was the opposite side and BC was the adjacent side. But if I start talking about, let's say, angle A, this is the theta I want to talk about, then these things will change. This, because in this scenario, when I'm talking about angle A, BC is going to be the opposite side, because this is opposite to theta, right? So BC will become the opposite side, and AB would become the adjacent side. So that is how these things work, right? So theta, the opposite side and adjacent sides are not fixed sides. Those are relative to the angle we are talking about, right? So you have to be very careful on what you just don't memorize opposite by hypotenuse. Just understand what opposite means, like the farther the side which is away from the theta upon the hypotenuse of the right triangle. This is how you have to understand and then remember. Not just remember blindly, you have to understand what you're remembering, right? So let's move on to the next slide. I think we have a table here that gives us all the trigonometric ratios for different angles. This is something that you might have already memorized. People who have not memorized should memorize it as soon as you can, because this is something that is non-negotiable. You have to use them so many times that if you if you think that I'm gonna refer to these every time I'm gonna face these problems, it's gonna be a hassle, right? So this is something like multiplication tables, something like that. You have to remember them, right? It becomes very useful. And yeah, these are the trigonometric ratios. And just pause the video if you don't have if you don't remember them, and note down every uh, actually you just have to remember from sine to tan only, because cot, sec and cosec are reciprocals of sine, cos and tan, right? So once you remember these values, then you can just reverse them, and then that's how you can remember. Becomes, it's half the word. It looks very big, but you just have to remember half the table. Okay, so let's move on to the next topic, which is finding out ratios for angle greater than 90 degree, right? For angle lesser than 90 degree, you can use the trigonometric ratios for 30 degree, 60 degree, all these you already know. But what if I give you an angle which is greater than 90 degree, or something which is less than 0 degree, right? So angle wise, let me go to my blackboard here. Angle wise, some basic things about angles is that in angles, whenever we are trying to find out the angle, okay, I need to change my eraser. Stroke eraser, yeah, this is better. Okay, so if I am dealing with a with an angle, then oh my god, funny. Okay, cool. So if I'm dealing with an angle, we are always calculating the angle from the x-axis in an anti-clockwise fashion. Let me repeat that statement again. Whenever we are dealing with angles, whenever we are measuring angles, the most common way is to take the angle from the x-axis in a anti-clockwise fashion. So this is the general way of taking the angle. So if I want to find out the angle of a line which is in the fourth quadrant, so we know what the quadrants are like. So if this is X and Y, this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant, right? So if I am trying to find out an angle in the fourth quadrant, the general way to do this is like this, finding out this particular angle. So this will be greater than 270 degrees. So because this line, the negative y-axis is making an angle of 270 degrees. So that if the angle is in the fourth quadrant, it is gonna be greater than 270 degrees. But it can also be represented as minus of this angle, right? For example, if I give you an example, let's say this is 300 degrees, just an example. In that case, I can also represent this angle as minus 60 degrees, because the reason for minus is because I'm taking the angle in the reverse direction. It's a minus, it's a negative angle we are talking about, right? So when we are dealing with angle, there's two ways of representing. One is in the positive direction in an anti-clockwise fashion. If you're going, if you just keep on adding, right, 90 degree, 180 degree, 270 degree, 360 degree. So in 360 degree, it comes back to its original location, right? After that, if you keep on adding, it's just rotating in a single place. In the negative direction also, but this time you'll be going clockwise, minus 90 degree, minus 180 degree, minus 270 degree, and minus 360 degree, right? So that is how the convention works. Now if I want to find out the any random angle which is greater than 90 degree, let's say here I want to find out how much is 120 degree. I want to find out how much is sine of 120 degree. Maybe I want to find out how much is cos of 120 degree, right? So how would I find out these values is what we are going to discuss next, right? So there are a few steps that you need to remember, which is so when I try to find out the value of an angle, like for example the trigonometric ratio of sine 120 degree, if I want to find out, there are two things that I need to find out. What is the algebraic sign of that value, right? And second, what is the magnitude of this value, right? So the sign and you don't confuse it with sin sine, the trigonometric ratio. I'm not talking about this, I'm talking about this sign, the algebraic sign of sine 120. It's slightly confusing, the wording, so I'm writing it down for you. I'm looking for the algebraic sign of sine 120, right? So there is a mnemonic here: add sugar to coffee. ASTC, right? So this is a mnemonic: add sugar to coffee. What this means is that all A here stands for all trigonometric ratios in the first quadrant, no matter what trigonometric ratio you're taking, it's gonna be a positive value. So sine of if you look at the table that I just gave you a few minutes ago, you'll see all the values are positive because all the angles were between 0 degree and 90 degree. So that's why all the angles in the first quadrant will always be positive for any trigonometric ratio, be it sine, cos, tan, etc., etc. Okay. The second thing that we know about this from this mnemonic is the second one, S. S stands for sine and its reciprocal, right? Sine and the reciprocal of sine is cosec, right? So if you have any angle sine theta or cosec theta, and this theta belongs to 90 to 180 degree. So if you have an angle between 90 degree and 180 degree, in that case, sine theta and cosec theta will be positive. The rest of the trigonometric ratios will be negative. It's a very powerful mnemonic that gives you the algebraic sign. Okay, so let me write it down for you. In the second quadrant, sine theta and cosec theta are going to be positive. Rest everything else, cos theta, sec theta, tan theta, cot theta, all these four ratios are going to be negative. This is what this S in this mnemonic tells me. Okay, so can you guess what T tells me in the third quadrant? In the third quadrant, tan and its reciprocal cot theta, tan theta and cot theta would be positive. Rest of the trigonometric ratios will be what? Negative. Now again, let me explain it one more time. If I have an angle between 90 degree and 180 degree and 270 degrees, what I mean by this is I know that this angle is 180 degree. The negative x-axis is making 180 degree with the positive x-axis. So if your angle is between 180 degree and 270 degree, then tan theta and cot theta will be positive, but the rest of the signs will be what? It will be negative. So the last one is also very, very simple. It's the last in fourth quadrant, cos theta and sec theta. The reciprocal of cos theta is sec theta. These two are positive, the rest are negative. Okay. So this is the explanation of the first step in finding out the values greater than 90 degree. So here you might be seeing this, how to find ratios of angles greater than 90 degrees. So there are 4 steps in this. The first step we have figured out. So if I want to find out sine cos of any angle greater than 90 degree, with the first step, I can at least know what is the algebraic sign of the answer. I may not know what is the magnitude right now, which we'll discuss how to find out the magnitude, but I know the algebraic sign of it, whether it's a positive value, it's a negative value, I know. Based on the angle itself, where the angle lies, I can say it is a positive angle, it's going to be a positive ratio or a negative ratio. Okay. So the next one, the next step in finding this is express the angle as an addition or subtraction of 180 degrees, right? What I mean by that is this. The example was to find sine of 120 degrees. So the next step is either you write it as sine of 90 plus 30 or sine of 180 minus 60. I'll let you absorb this, right? So now check this out. 120 degree can also be written as 90 plus 30 or 180 minus 60, right? In the first case, 90 plus 30, you are using the help of y-axis. What I mean by that is this was the angle. This was the 120 degrees. This was 120 degrees. What you did is you said, oh, 120 degrees is nothing but y-axis, which is 90 degree at this, plus 30 degree, plus 30 degree. In the second case, you are saying, okay, the negative x-axis is located at 180 degree. So it is nothing but this x-axis minus 60 degree. Right. So this is the second step that you need to do. Any kind of angle, not just 120 degree. If it is 220 degree, you will have to write it as what? Sine of 180 plus 40 degrees. Right. Or you could also write it as 270 degrees minus 50 degrees. Remember, you have to either use one of the x-axis or the y-axis. Remember, y-axis is not just 90, it is also 270 degrees, right? So if your angle is in third quadrant, you will be using 270 minus or 180 plus. What happens if you are having an angle in the fourth quadrant? Let me give you an example. Here, let's say this is the angle. Here we are dealing with 300 degrees. So you can either write it as, for example, you need to find out sine of 300 degrees. So the next step would be sine of, instead of writing sine 300, I will be writing sine of 270 plus 30 degrees, right? Again, very simple step. You have to express the angle in terms of 90 degrees, 180 degrees, 270 degrees, 360 degrees, or anything along these lines, okay? Because these are the angles of the axis. So I can either write this as 360 minus 60 degree also. So remember what I'll try to visualize. I'll let you visualize what we are trying to do. Here this is the 270 degree axis, right? So 300 degree, I said it's this axis plus 30 degree, right? Or you could have also said, okay, this is the x-axis, which is 360 degree, complete 360 degree, and from that I am subtracting what? 60 degree. So take your time in understanding this, and then let's move on to the next step. Okay, so till now we have done two things. First, I identified what would be the sign of this value, like the algebraic sign of this value, whether it will be a positive value or negative value. I don't know the magnitude yet, but I know this, it's a positive value or negative value. The second thing I did was I expressed the given angle in terms of 90 degree, 180 degree, 270 degree, or 360 degree. One of these four things I have done, right? Now, the third important step is this. If you are using a y-axis, you have to change your function to a complementary function. What I mean by that is sine theta will become cos theta will become sine theta, tan theta will become cot theta, and so on. So if you remember, sine 90 minus theta is cos theta, and this is why we call sine theta and cos theta what? The complementary angle. The complementary angles, right? Similarly, tan and cot will also have the same kind of relationship. That's why we call them the complementary angles. If you are using any angle that is along the y-axis, which means if you are using 90 degrees or 270 degrees, in these scenarios, you have to change your given, whatever the trigonometric ratio is given in the question, you have to change it to its complementary form. You have to change it to its complementary form. But if you are using 0 degrees, 180 degrees, or 360 degrees, which are angles of the x-axis or minus x-axis, right? These are angles of the y-axis and minus y-axis. So if you're using angles along the x and minus x-axis, in these cases, you'll do what? You will not change anything about the question. You'll just remove 360, 180, or 0, and then you'll do the question, right? Now, you'll see this happen in action and you'll understand more. One second, I'm going to show you how it is done, right? So the question initially was sine of 120 degrees. So I know sine in the second quadrant, the first step was to identify the algebraic sign. So I know this answer is going to be a positive answer because 120 degree is in the first quadrant between 90 and 180. So I'm trying to find out the sine of 120. So that's why this is going to be a positive value, right? After that, I write sine of what? 90 plus 30. Now, sine, I'm using 90, which is a y-axis angle. So this will become cos of 30. So this is nothing but root 3 by 2 from the trigonometric ratio table. I know what is cos 30 from the trigonometric ratio table. So this becomes cos 30 root 3 by 2. So did you understand how I did this? Right. Let's move on to the next one. Sine, like let's do it in a other way, like a different way. This I can also write this as sine 180 minus 60 degree. 180 minus 60 degree. Now, since I used 180, I don't need to make this complementary. I can just write sine 60. So sine 90 plus 30, I can write it as cos 30. Sine 180 minus 60, I can simply write as sine 60 because I'm using a x-axis angle, which is 180 degrees. So this becomes nothing but same 3 by 2. So no matter in which way you solve, you'll always get the same answer, right? Let's do some other questions also. Let's do some other questions. Okay, let's do some questions. Okay, let's find some questions. Never mind, I'm going to give you questions from my side only. Okay, let's find out cos of 150 degrees. Cos of 150 degrees. So cos of 150 degrees can be, first of all, let's figure out what will be the sign. What will be the algebraic sign of this? So I know add sugar to coffee, and 150 degree is between 90 degree and 180 degree. So it is in the second quadrant. So from here, I know whatever answer I will get, it will be a negative answer, right? So this I have to remember. I'm just keeping it brackets. I'll find out the magnitude and then I'll put a minus sign at the end, because I know cos of 150 degree is going to be a negative number, right? It's going to be a negative number, right? So 150 degree can be written as 180 degrees minus 30 degrees, right? Or it can also be written as cos of 90 plus 60 degrees, right? So let's do this one. I'm using an x-axis, so no need to change the function itself. Cos will remain cos only. So cos 180 minus 30 is cos 30. Cos 30 is nothing but root 3 by 2 with a minus sign. So we have to put minus sign at the end because this is the second quadrant angle. Okay. Cos 90 plus 60, in this case, this would become sine of 60, because I'm using 90 degree. 90 degree, if I'm using 90 degree or 270 degree, cos will become sine, sine will become cos. So cos of 90 plus 60 becomes sine of 60. Sine 60 is root 3 by 2, but remember this is, I need a minus sign with this, so minus root 3 by 2. Minus root 3 by 2. Right. Let's do one more, and then let's move forward. Tan of 225. Okay. Tan of 225 degrees. So first of all, let's locate 225 degrees. 225 degrees is located between 180 degree and 270 degrees. So if I break it, this would become 180 plus 45 degrees. So this is nothing but tan 180 plus 45 degrees, which is nothing but tan of 45 degrees. 180 plus 45, I'm using 180, so no need to change the function to cot, right? So tan 45 is nothing but 1. And I know it's a positive value because in the third quadrant, tangent are positive. So in case I was finding out cos 225, and I write cos of 180 plus 45, this would become cos 45 with a minus sign, because in the third quadrant, only tangents are positive. Cos and sine, if you are trying to find out for the same angle, this will become minus, right? So this is minus 1 by root 2 in this case. Okay. So let's continue. Okay. Next is the trigonometric identities. Okay. So let's see what are the different trigonometric identities. I hope you know these ones. These are pretty simple. Sine and tan are kind of, we call them odd functions, because when you put a negative angle inside it, the negative sign comes outside. What I mean by that, if I want to show you with an example, let me go to the board. Yeah. If I want to find out how much is sine of minus 60 degree, this would be equal to minus of sine 60 degree. And we know sine 60 is root 3 by 2. So the answer for this is root 3 by 2. Cos, on the other hand, if I want to find out cos of minus 60 degree, this is equal to cos 60 degree itself, which means this is simply half, right? No negative sign in this. So cos, we call cos an even function. You'll discuss in detail why, but for right now, just remember that sine and tan, we call them odd functions. And if you put a negative angle inside it, the negative sign comes outside. Okay. And if you put a negative angle inside cos, it actually just it's equal to the positive angle also. So just remember this fact. Details you will learn when you actually study trigonometry and functions in your math subject, right? So let's move on to the next set of trigonometric identities. Let me move myself a little bit down. Okay, down we go. Okay, so these are very basic trigonometric identities. You should have already dealt with them in 9th and 10th standard. Sine square plus cos square is 1, 1 plus tan square is sec square, and 1 plus cot square is cosec square, right? This ones will be new. So I want you to write it down somewhere, paste it somewhere you can see, right? And then try memorizing them, because these will be very, very useful when you are dealing with, especially projectile motions and different kind of motion scenarios in physics, right? So in those cases, trigonometry will be slightly useful, right? So these are, there are a lot of trigonometric identities, but these are the ones that you need initially to figure out the physics. Okay, so write this down. If you don't know any of them, just write them down, memorize them, and that's it, right? And that that should be everything. Let's move forward. Okay, let's talk about the application of trigonometry, as in how do we apply trigonometry in physics. The most common scenario, there are different scenarios, but the most common scenario is this. For example, if you know the distance, for example, finding out vertical height of things is not very easy. For example, if you have a very huge building in your neighborhood, it's very difficult to essentially put a rope down and measure, right? If it's a very tall building, it will be very, very difficult. What you can do is you can stand. Let me draw the diagram for you. If you have a very tall building, you don't know the height of, like, let's call it H for now, right? This is the building, right? And this is a horizontal path, and let's say this is the sun. This is the sun, and you are standing somewhere here, and the sun rays are coming like this, and they're coming to you, and you somehow figured out there are devices that let you find out what is this angle with the horizontal, right? Let's say you found out, okay, this angle is 30 degrees. Let's say it's 45 degrees. Make it easy. Let's say this is 45 degrees, right? And finding out horizontal distances is pretty easy. All you need is a vehicle. You just check the odometer and you write to that location, and you will find out, okay, this is what, 100 meters, or let's say 300 meters. This, okay. So how do you find out H based on that? It's very, very simple. You just make this angle, right? Complete this triangle. So this triangle will be what? It's a right triangle, right? So if I want to find out this height, so let me isolate this triangle. Okay, this triangle is something like this. This is this height, right? This is actually the height of the person. So I'll call this HP, and this is the height of the building minus HP. So H minus HP is the side of this triangle, and this is 300 meters. Okay, and this angle is nothing but 45 degrees. Now I know trigonometric ratio tan of 45 would represent the opposite side, which is H minus HP, divided by the adjacent side, 300 meters. I'll give you 2 seconds to absorb this particular thing that I just said. Tan of 45 degrees is what? Its opposite side divided by adjacent side. In this triangle, the opposite side is H minus HP, which is height of the building minus height of the person, right? So I put it here and 300 here. So this is the ratio we are talking about. I know tan 45 is nothing but 1. So H minus HP is 300. So the height of the building is 300 plus height of the person. So let's say if the person is 1.5 meters, just an example. He's a very short person, 1.5 meters. So the height of the building would be 301.5 meters. So that is the most basic application of trigonometry in finding out height of things that is difficult to measure, right? So this is the whole scenario. So this is the most basic application. There are much more complicated and in-depth application of trigonometry in physics which you will face, but if you are understanding this, that means you will be able to figure out those also. Okay, so take your time and then analyze what I just said, and then figure out what you understand and what you don't understand. Okay, let's move on. Let's move on to something new. This is the coordinate geometry. Okay, coordinate geometry. Coordinate geometry is the discussion of physical, not like if you have a straight line, if you have a curve, how can you represent that with a mathematical equation? That is the whole gist of coordinate geometry. You have a coordinate plane which you represent using the x-axis and the y-axis. The distances are given in distances in the horizontal are given in x-axis, and distances in the vertical are given in y-axis. And if you establish a relationship between y and x, it will give you an actual thing in the coordinate plane. It may be a straight line, it may be a circle, it may be a parabola. There are a lot of things that have equations, right? Different equations. So I don't know if you have heard this before, but if you have a straight line, if you have a straight line in a coordinate plane, let's say this is x, this is y, this is x axis, this is y axis, and if you have a straight line running like this straight line will have an equation which is given by y equals mx plus c. That means any equation that is something like y equals to 2x plus 3, y equals to 5x plus 7, right? You can also have minus y equal to minus 3x plus 2, y equals to 4x minus 3. These kind of equations will give you straight line in this coordinate plane. So now let's try to figure out what is the significance of these numbers, because y and x, so it will be there. These are variable quantities. These constant quantities like 2, 5, minus 3 and 4, it will define how the line will look. Sometimes the line, in this case the line is like this, sometimes it will be like this, sometimes it will be like this. So I'm going to a website called desmos.com, right, and we'll test you what is the use of these numbers. Okay, so let me tell you my experiment, like what I'm planning to do. Let's go to desmos.com. Let me move this. Cool. Awesome. Okay, so this is that graphical website that I was talking about. Let me see if I can make this. Okay, cool. Okay, so in on the left hand side, I'll write the equation y equals to 2x, and on the right hand side, it will immediately show me the straight line that is associated with it, right? So how did I get y equal to 2x to this straight line? I just plotted all the points. So first of all, you can take x 0, y will also come out 0, right? Then you take x equals to 1, y will come out to be 2. So you plug in 1 comma 2, then 2 comma 4, 3 comma 6, right? So if I point like this, it will show, see, this is 2 comma 4. If I click on this, this is actually showing me what number this is, 2 comma 4. This is 1 comma 2. See, this is 1 comma 2. It's also passing from 0 comma 0. So every linear equation in math is actually representing a straight line in the coordinate plane. So let me repeat a very important statement again. Every linear equation in math represents a straight line in the coordinate plane. Okay, so let me see what this number 2 has, like what is this coefficient of x is having. Okay, so let me plug in y equal to 1x. Let me see how it's affecting. Okay, y equals to 3x. Okay, let me do one more, y equals to 4x. So based on this, can you tell me what is happening? What does this number do? So 1x, 2x, 3x, and 4x, what is it changing? So if you want to know which one is which one, just look at the colors. Okay, so this one blinking right now is 1x. This is 2x. This, the one blinking right now, is 2x. This is 3x, and this is 4x. So take your time, pause the video and think about this. What is this number signifying, right? The numbers are signifying the slope of this line. The word you're looking for is known as slope. Slope. Slope means what is the angle that the line is making with the horizontal. With the horizontal. So if you increase the coefficient of x part, like if you increase from 2 to 5, the slope will increase. So if your line is something like this, y equal to 2x is something like this, y equal to 5x will be steeper. It will have higher slope. It will have higher angle with the horizontal, or in this case, I can say the x-axis, right? So this is, so in this equation, y equals to mx plus c, m represents what? The slope. right? Instead of having a bunch of equations, I can also write, let me remove everything else, and I can write y equals to mx and put a slider on it, right? And then when I move this slider, you can see how decreasing the value will make the line go in this, right? And increasing the m value will make it go up. Tell me if you understand. Okay, so now let's see what is the effect of the other number that you add at the end. Like if you see the equation, it is y equals to mx plus c. So there is a constant that is added up here. Okay, so for this particular experiment, let's keep this mx constant, like just mx plus okay, where's plus? Okay, this is plus c. Okay, and then I'm going to put a slider for both m and c. Now, the thing is, I'm going to keep m constant because I want to see how c, the intercept number, the c number affects the equation. How does c affect the equation? For that, m I'm going to be keeping constant. Okay, and let's slide c and see where this equation is going. So this is the line y equal to mx plus c, where m is 1 and c is 1. So this is actually the equation of y equal to x plus 1. This is the line y equals to x plus 1 because m is also 1, c is also 1. Now let's change the value of c and see what happens. Okay, so I'm going to increase the value of c. What is happening? What is happening? Just look at this value, the value where the line intersects the y-axis. Just look at that, because otherwise you'll be seeing everything is moving somewhere. But if I want to just look in one direction, just look in the vertical direction, what is happening. Okay, so I'm increasing the value. What is happening? The value of the intercept, we call this the intercept, the length, the point where the line intersects the y-axis. The y-axis is like this, and this is the line. So I'm talking about this particular point. You see 0, 4. This is where the line is intersecting the y-axis. If you look at that, if you increase the value of this c, the line keeps on climbing up and up. In other words, I can also say the intercept of the line keeps on increasing. So if you look at this, c is now 5 and this line is intersecting at 0, 5. I'm going to decrease this to 4 and you will see that the line is now intersecting at 0, 4. Okay, let me continue this. Let me reduce it to 3, or let me reduce it to 2, and you will see that this line is intersecting the y-axis at 0, 2, right? So what do you infer from this? What do you infer from this? What is the logical conclusion for this? This means that y equals to mx plus c equation, m represents slope and c represents what? The intercept, right? And what is intercept? Intercept is where the line intersects y-axis, right? And this number can be positive, negative, anything. Okay, so if in an equation, if you have y equals to 3x plus 100, that means what? The line will intersect at 0, 100. That is something that you can know. And another thing, so from this equation, there is two information you'll get. Whether the slope is like the slope of 3 will look something like this, and this distance from the origin would be 100, right? So whenever you are given a linear equation, from that you can pretty much extract a lot of information about the straight line that it will make. Only thing that you have to know what represents what. So in y equals to mx, m is the slope, c is the intercept, right? So I want to show you some other equations also. Like for example, instead of linear equation, in linear equation, power of y is also 1, power of x is also 1. In quadratic equations, you have what? Square. Remember, quadratic equation, you have x square. You used to solve using quadratic formula. So instead, instead of these linear equation, what if I put like y equals to x, and in the function from there I'll put x squared. See what this becomes? Y equals to x squared. This is known as a parabola. This particular figure, the when you increase the power of x, you will find, or y also when you increase, you will find different figures that you can make, or different real life figures like circles, parabolas, hyperbolas. Those things you can make using mathematical equations. Let me show you a circle also, right? So let's keep x square. Let's add y square. Right, I'm increasing the power of x, I'm also increasing the power of y. So instead of y equals to mx plus c, I'm using x square plus y square is equal to, let's say, 4. See what it became? It became a circle, right? So any kind of figure that you want can have a mathematical analogus, right? We can have an equation to describe that particular figure. So in real life, you see a lot of shapes and sizes, but as an engineer, when you become an engineer, you cannot just say ki make a straight line, or to the computer. For example, you are a computer engineer, you want the computer to make a straight line. You cannot tell them qualitatively, right? You cannot say them, oh, okay, make a straight line. That is a logical statement. Computers do not understand logical statements. Now they do, because of all the advancement. But if you think in the hardware level, they do not understand logic. They understand what? Plus one and zero, zero and ones binary. They only understand ones and zeros and math, right? So that's why these are important. These equations are important. If you want to tell your computer to make a circle, you cannot say make a circle. You say plot x square plus y square equal to 4. That is the use of this. Okay, as an engineer, you have to understand how to convey shapes, sizes, locations using math. Okay, so that is the purpose of this particular course. Let's move on ahead. Okay, let's move on ahead. So this is done. This is done. This is done. Okay, so here is some of the important issues that I have, important points that I have noted down here. You can note down. Right, this is very nice. Let's move on to the next one. Y equals to x square. I just showed you the graph there, right? This is a non-linear. Okay, the word linear, it means straight line when powers are 1. Quadratic means powers are 2, right? You can say non-linear, or you can also say quadratic. Okay.